Welcome back, everyone. So we will continue with the feedback part. Just close this. So feedback, related to the concept of visibility is feedback. This is best illustrated by an analogy to what everyday life would be like without it. Imagine trying to play a guitar, slice bread using a knife, write using a pen. If none of the actions produce any effect for several seconds, there would be an invariable delay before the music was produced, the bread was cut, or the words appeared on the paper, making it almost impossible for the person to continue with the next strum, cut, or stroke. Various kinds of feedbacks are available for interaction design, audio, tactile, verbal, visual, and combination of this. Deciding which combination are appropriate for different types of activities and interactiveness is central. Using feedback in the right way can also provide the necessary visibility for user interaction. So the most useful for feedback or for design principles, so this is the basic, are first the sound. You could provide a text when the person hover on your app. You can provide the tactile or any feedback related to touch or sense is not as useful as the sound. Verbal words such as a warning or a dialogue box, a text dialogue box. Visual. So the sense that are most useful is audio and visual that is activated in this feedback, because this is related to the concept of perceptual awareness, which we discussed in the previous video, that the most useful are actually those that the most useful are eyes, the visual, and then the hearing part. So that's the feedback. Also, this is central to any design. It needs to be able to provide effect or show you the effect, because it's hard if you do not know the effect of your action. It's kind of like choices in life, right? If you're not, if something that is bad to you does not provide immediate effect, it will be it will be disrupted to your health. Additionally, some people are have this immediate effect on their body. That's why they are able to course correct when something is not doing well with their diet or their health habits. And some people do not see the immediate effect. That's why it's harder for them to course correct. Constraints. There are various ways that can be achieved. So, additional for this feedback is that don't judge people with a body that does not have provide immediate effect. So you're lucky if you are one of the people that has immediate effect, but for others it's like an ADHD or a problem with reading. They're just not aware. Okay. Constraints. There are various ways that this can be achieved. A common design practice in graphical user interfaces is to deactivate certain menu options by shading them gray, thereby restricting which actions are permissible at the stage of the activity. See this figure. One of the advantages of this form of constraining is that it prevents incorrect options being selected and thereby reduces the chance of making a mistake. So remember this, guys. This is a basic principle as well. Constraints. So this is the third. First is visibility. Constraints. It's like the windows on your screen, right? It's limited. So you have to maximize the space when you're trying to navigate your PC when you're working. So try to minimize the motion or the invisibility. Maybe it's better to have this in one window, or it's almost better to always have this in just one window because it provides constraints. It provides visibility and it provides feedback, an immediate feedback that you can see. So the key thing here is your senses and the perceptual senses, such as your vision and hearing part. Okay, make sure that you also get notification from the important applications that you use in your everyday life. So that's the takeaway. But yeah, restricting counterintuitively actually make us um, navigate or the design allow for lesser cognitive load. So it's better design overall. So the most common use for this is menu options. So once you click that, it limited the options at a given time when you click the menu, like in Word or in PDF. When you click some menu that provides another set of options that's not included on your basic navigation, it will disable or make the other action gray. So you're kind of like digging deep, such as this. For example, my notes started with Roman numeral and then letter and then one. So once you're in this one, you cannot really move or go on other places because it's organized, and you can only modify things inside this one because that's the only thing you access. So it's kind of the same principle. It's like being clean and organized. So I'm mainly showing restricted availability of options. The use of different kinds of graphical representations can also constrain person's interpretation of a problem or information space. For example, flowchart diagrams show which objects are related to which, thereby constraining the way that the information can be perceived. The physical design of a device can also constrain how it is used. For example, most door locks are designed to allow keys to be inserted one way only. So the available graphical representations that you use to modify the interface or to input to a device, it also affects this constraint. So the flow chart, so it also affects because the functionality of that different interface is different. So the objects is also limited based on that interface. That's why it's important the situational awareness here to know what's the available options because often we are not aware of the available options or the limitations of the device that we are using. We just learn to use it. We don't know that in detail on how it really works. We just know it in its higher model framework, just like we've discussed in the previous video. So a physical design of the device, like door locks, designed to allow keys to be inserted in one way only, right? Consistency. This refers to designing interface to have similar operations and use similar elements for achieving similar tasks. In particular, a consistent interface is one that follows rules, such as using the same operation to select all objects. For example, a consistent operation is using the same input action to highlight any graphical object on the interface, such as always clicking the left mouse button. So consistency actually provide us or persuade us to do things because it's consistent, it's the same, and additionally, it also provide organization. Other than organization, it provides rules, just like the rules that our constitution or our public official create. It reduces the cognitive load for the next uh, lawmaker because it allows them to use the cognitive energy that has been thought of before. So it compounds and the system becomes weak because of this um, compound effect. Inconsistent interface, on the other hand, allow exceptions to a rule. An example is where certain graphical objects, for example, email message presented in a table, can be highlighted only by using the right mouse button, while all other operations are highlighted using the left mouse button. The problem with this kind of inconsistency is that it is quite arbitrary, making it difficult for users to remember and making its use more prone to mistakes. Interfaces, especially when many different operations need to be designed. For example, consider how to design an interface for an application that offers hundreds of operations, such as word processing application. This is simply not enough space for 1,000 buttons, each of which maps to an individual operations. Even if there were, it would be extremely difficult and time-consuming for someone to search through all of them to find the desired operation. A much more effective design solution is to create categories of commands that can be mapped into subset of operations that can be displayed at the interface. For instance, via menus, this solution is both consistent and highly learnable. So the similarities is of organizing the meaning or the function provides meaning or relationship to those, and it doesn't require the search or cognitive load that require us to recall or search something. We just need to recognize it if they are related, kind of like a sentence. Word itself does not mean anything, but if it's combined with its related meaning in a sentence, then it provides a powerful combination. So that's the power of consistency. Affordance, this is a term used to refer to an attribute of an object that allows people to know how to use it. For example, a mouse button invites pushing, and so doing activating clicking. By the way, it's physically constrained in its plastic shell. At a simple level, to afford means to give a clue based on Norman in 1988. When the affordance of a physical object are perceptually obvious, it's easy to know how to interact with it. For example, a door handle affords pulling, a cup handle affords grasping, and a mouse button affords pushing. The term has since been much populated in interaction design, being used to describe how interfaces should make it obvious as to what can be done when using them. So it leverages again our previous experience, or because the clue on based on our previous experience allow us to learn this faster. Therefore, it's better designed. So for example, the mouse, because of its constraints, you automatically have a clue on how to use it. So it doesn't it doesn't require like rocket science for you to be able to use it. It's just there because you have a previous knowledge on how this works. It's the same with design. For example, graphical elements like buttons, icon links, and scroll bars are discussed with respect to how to make it appear obvious how they should be used. Icons should be designed to afford clicking, scroll bars to afford moving up and down, and buttons to afford pushing. Don Norman 1999 suggests that there are two kinds of affordance, perceived and real. Physical objects are said to have a real affordances like grasping that are perceptually obvious and do not have to be learned. In contrast, user interfaces that are screen-based are virtual and do not have these kinds of real affordance. Alternatively, screen-based interfaces are better conceptualized as perceived affordance, which are essentially learned conventions. However, watching a one-year-old swiping smartphone screens, zooming in and out on image with their finger and thumb, and touching menu options suggests that kind of learning comes naturally. So basically, in this affordance, you're trying to know your previous history, the previous history of the people that you are targeting, so that you know what is their experience and how can you can ask yourself how can you integrate that previous experience to your design. Summary: many designs try to cram too much into a screen full of space, making it unwieldy for people to find the information in which they are integrated. Removing design elements to see what can be discarded without affecting the overall function of the website can be a salutary lesson. Unnecessary icons, buttons, boxes, lines, graphics, shading, and text can be stripped, leaving a cleaner, crisper, and easier to navigate website. However, graphics, shading, coloring, branding, and form can make a site aesthetically pleasing and enjoyable to use. Good interaction design involves getting the right balance between aesthetic appeal and the optimal amount of and kind of information. So we'll move next to the summary. Again, guys, thank you for watching. See you on the next video, please.